Welcome to Introduction to Computer Programming using C. This is your very first step into exciting a world of coding. So in this course, you learn how to write, compile, and run your own programs from scratch. If you have never coded before, don't worry. We'll start with the basics and slowly work our way up to more challenging problems. By the end, you'll be confident using C and ready for more advanced programming classes. But before we dive in, here's a little inspiration. Programming isn't just about computers, it's about solving real world problems. Every app you use, every game you love, every system that makes life easier was made by a programmer. By learning how to program, you're not just consuming technology, you're learning how to create it. And that opens up a world of possibilities for your future. So in this course, all about hands-on learning. You won't just sit back and listen, you'll actually be coding, experimenting, and solving problems yourself. We'll begin with basics like printing hello world on the screen and gradually move on bigger concepts such as arrays, functions, and even memory management. Think of this as your programming foundation. Once you master these skills in C, you'll find it much easier to explore other languages like Python, Java, or C++. So by the end of this course, you'll be able to understand the fundamentals of C, including syntax, variables, and loops, develop logical thinking and problem-solving skills through algorithms and flowcharts, write, run, and debug your own C programs, work with arrays, functions, and even pointers, and most importantly, gain the confidence to build your own programs and elaborate with others. So always remember that programming isn't about memorizing commands, it's about solving problems. So before we dive into programming languages, let's answer a simple question. What is programming? Programming is the act of writing instructions a computer can follow. So imagine giving a robot step-by-step directions. Whatever you specify, it executes exactly. Without code, a computer is just a metal and circuits. With code, it becomes a tool that can play music, browse the web, run apps, crunch numbers, power games, and even guide rockets. In this course, we'll learn how to do all of that step by step, starting with the C language. Now let's tackle another question. If programming is about giving instructions to a computer, then what exactly is a programming language? A programming language is simply our way of communicating with computers. You see, computers only understand zeros and ones, that is binary. But imagine writing hundreds of zeros and ones just to display hello world. That would be nearly impossible for us. That's why programming languages exist. They act as translators, letting us write instructions in a form we can understand, and then converting those instructions into something the computer can actually run. Programming languages are divided into different types. Some are very close to how the computer actually works. These are called low-level languages. Others are designed to be more beginner-friendly and making coding easier. These are high-level languages. There are also special kinds of languages created for specific tasks like HTML for building web pages or SQL for managing databases. Let's talk about low-level languages. There are two main examples, machine language and assembly language. Machine language is made up of pure zeros and ones. It's extremely fast, but almost impossible for humans to read or write. Assembly language is one step above that. It uses short commands like MOV or ADD, so it's easier than binary, but still closely tied to the computer's hardware. Nowadays, very few people code directly in machine or assembly language. Instead, we mostly use higher level languages like C, which are more easier to work with. High-level languages are much closer to the way humans think. Procedural languages like C follow step-by-step instructions. Object-oriented languages such as Java, C++, and Python are built around objects. making programs easier to organize and reuse. Functional languages like Haskell treat programs as mathematical functions. Scripting languages such as Python or JavaScript are often used for quick tasks or automation. And declarative languages like SQL focus on describing what we want the computer to do rather than how to do it. In this course, we'll focus on procedural programming, specifically using the C language. Some languages are domain-specific, meaning they're designed for a specific purpose. For example, MATLAB is used for mathematics, HTML is for building web pages, and Verilog is for hardware design. We also have markup languages like XML and Markdown. So these aren't true programming languages, but they are useful for formatting and organizing information. This is C, the programming language we'll be learning in this course. C is powerful, fast, and has influenced many other languages. Learning it will give you a strong foundation in programming. C is a general-purpose, high-level programming language created by Dennis Ritchie at Bell Labs in the early 1970s. Its first major use was in developing the Unix operating system, and the very first computer where C was implemented was the DEC PDP-11 back in 1972. So yes, C has been around for decades, but even though it's old, it remains highly important today because many modern languages like C++, Java, and even Python were influenced by it. So why C? C is a great language to start with because it is simple to learn and follows a structured style, meaning we write programs step by step in an organized way. It is also the foundation of many other languages like C++, Java, and even Python. Another big strength of C is that it produces fast, efficient programs and can even work with low-level tasks like memory and hardware. C is also very flexible since it can run on many different computer platforms. But most importantly, C teaches us the core fundamentals of programming like loops, functions, and problem solving. Once you learn C, it becomes much easier to move on to other programming languages later. Before we start coding, we need to set up our computers for programming. Just like you need a pen and paper to write, we also need special tools to write and run code. The main tools you'll need are a text editor, where you will write your code, a compiler, which translates your code into something the computer understands, and a terminal or command prompt, where you will run your programs. For this course, we'll make it simple by using code blocks. It includes everything we need in one package. The setup is easy. Download and install code blocks, test if it works, create your first project folder, and you're ready to start coding. So don't worry if this sounds technical, we'll go through the setup together in our next class so everyone's computer will be ready for programming. Now let's write our very first C program, the classic Hello World program. This is the traditional first step for every programmer. All it does is print a simple message on the screen, this is the code. It may look like a little intimidating at first, but let's break it down. So, include stdio tells the computer we want to use printing functions. Integer main or int main is where the program begins. Inside we have a print function that is hello world. This is what actually prints our message. And finally, return 0 tells the computer that the program finished successfully. So when we run this, the computer will simply display hello world on the screen. That's it, your first working program. Alright, let's try running our very first program inside CodeBlocks. First, I'll create a new project. Then I'll choose console application. Then select C language. Let's try name the project Hello World. Next, select the compiler, go to the sources, click main. Now code blocks give us a basic template, but I'll clear that and type in our program. Include stdio.h. So this is the code, our Hello World program. Once the code is ready, I'll save the file. Next, I'll click build and run, which is here. This step compiles the code, meaning it translates into something the computer understands. And here we go. Our output window shows Hello World on the screen. That's it. You've just seen how to write, compile, and run your very first C program in CodeBlocks. Let's see how to run it step by step. First, type the code exactly as shown. Next, save the file as Hello C. After that, we compile it. This step translates our code into something the computer understands. Once it's compiled, we run the program. And finally, if everything works, you'll see the message Hello World up here on your screen. Congratulations, once you get that output, you've officially written and run your very first C program, which means you're officially a programmer. Alright, that's the end of our introduction to C programming. We learned why C is a great starting language, how a simple program looks, and even ran our first Hello World code together. I hope this session gave you the confidence to start exploring programming on your own. Thank you for listening. Please like and subscribe on this channel so more videos will come.